morning. The topics that will be discussed today are the one sample and the two sample mean test. For the one sample mean test, this is used when the sample mean is being compared to the perceived population mean. However, if the population standard deviation is not known, then the sample standard deviation can be used as a substitute. Here, we will be using the formula z is equal to x bar minus mu over sigma divided by square root of n, where x bar is the sample mean, mu is the hypothesized value of the population mean, sigma is the population standard deviation, and n is the sample size. For our example problem, we have there ABC company claims that the average lifetime of a certain tire is more than 26,000 kilometers. To check the claim, a taxi company puts 40 of these tires on its taxis and gets a mean lifetime of 26,850 kilometers. With a standard deviation of 2,350 kilometers, is the claim true? Use a test at 0.05. For our problem statement, is the claim true that the average lifetime of a certain tire is more than 26,000 kilometers? For our hypothesis, we have there our null is mu is equal to 26,000 and our alternate is mu is greater than 26,000 kilometers. For our level of significance, we have alpha is equal to 0.05. Our tabular value of z, that is 1.645. Again, this is from our student's t distribution table. Our statistics is one sample mean test. Okay, to compute for that, we have z is equal to x bar minus mu over sigma over square root of n. And we have here 26,850 minus 26,000 divided by 2,350 over square root of 40. And this gives us a computed value of 2.29. For our decision rule, if the z computed value is greater than or beyond the z tabular value, we reject the null hypothesis. For our conclusion, since the z computed value of 2.29 is beyond or greater than the critical value or tabular value of 1.645 at 0.05 level of significance, we reject the null hypothesis, which means that the average lifetime of a certain tire is more than 26,000 kilometers. To illustrate that, we have here our normal curve. Our tabular value is 1.645. So it's here. Okay. So for the computed value, it's here. Okay. So again, this is our rejection region. Next is a random sample of 100 recorded deaths during the past year showed an average lifespan of 70.2. Assuming a population standard deviation of 7.8 years, does this seem to indicate that the mean lifespan today is greater than 68 years? So use 1% level of significance. So for our problem statement, is the mean lifespan today greater than 68 years? For our hypothesis, we have there our null. The mean lifespan today is 68 years or is equal to 68. And our alternate hypothesis is the mean lifespan today is greater than 68 years. For our level of significance, we have their alpha at 0.01. So our tabular value or critical value of Z is 2 point. This is we have 0.01 for one-tailed test. We have there 2.33. Okay, again, please refer to our students' T distribution table. For our statistics, we have one sample, mean test. Okay, so for our computation, we have Z is equal to 70.2 minus 68 divided by our standard deviation of 7.8 divided by square root of 100. Okay? So for that, $2.82. For our decision rule, if the Z computed value is greater than or beyond the Z tabular value, reject the null hypothesis. So for our conclusion, since the Z computed value of 2.8205 or 2.82 is beyond the critical value of 2.33, at 0.01, this is 0.01 level of significance, the research hypothesis is accepted, which means that the mean lifespan today is more than 68 years. So to illustrate that, we have here our normal curve. Our critical value or tabular value is 2.33 and our computed value is located here, 2.82. So again, it belongs to the rejection region. For our two sample mean test, okay, so it is used when comparing two separate samples drawn from or at random taken from a normal population to test whether the difference between the two values of x bar 1 and x bar 2 is significant or can be attributed to chance. The formula used is Z is equal to x bar 1 minus x bar 2 divided by the square root of variance 1 over n1 plus variance 2 over n2. For our example problem, an admission test was administered to incoming freshmen in the colleges of nursing and veterinary medicine with 100 students each. Each was randomly selected. The mean scores of the given samples were 90 and 85, and the standard deviations of the test scores were 15 and 10 respectively. Is there a significant difference between the two groups? So, for our problem statement, is there a significant difference between the scores of the two groups of incoming freshmen in the colleges of nursing and veterinary medicine? For our hypothesis, our null, there is no significant difference between the scores of two groups of incoming freshmen in the colleges of nursing and veterinary medicine, or we can express this as mu1 is equal to mu2. And then for the alternate, we have there is a significant difference between the scores of the two groups of incoming freshmen in the colleges of nursing and veterinary medicine, or we can express this as mu1 is not equal to mu2. Okay, So for our level of significance, we have there alpha at 0.01. So our critical value or tabular value is 2.58. Again, please refer to our student's T distribution table. So for the our statistics is two sample mean test. For our computation, we have there z is equal to x bar 1 minus x bar 2 divided by the square root of variance 1 over n1 plus variance 2 over n2. Okay, so for our problem, we have here 90 minus 85 divided by the square root of 15 squared over 100 plus 10 squared over 100. Okay, so this is equal to 2.77. So for our decision rule, if the z computed value is greater than or beyond the z tabular value, we reject the null hypothesis. So since our z computed value of 2.77 is beyond the critical value of 2.58 at 0.01 level of significance, the research hypothesis is accepted, which means that there is a significant difference between the test scores of the incoming freshmen in the colleges of nursing and veterinary medicine. Okay, so to illustrate that, we have here, again, our normal curve. Our computed value or our tabular value is 2.58. Our computed value is 2.77, which belongs to the rejection region. Okay, so that's all for now. Thank you very much and God bless.